Hello, ladies and gentlemen, and welcome back. We're looking in this video at question number 5 on our 2018 Cimc paper. There are 5 pairs of integers, a, b, where both the numbers are between 0 and 10, for which the points 1, 1, 4, 5, and ab form a triangle that has area 6. Okay. What are these 5 pairs of integers a, b? So once again, they're telling us that we've got 5 twice, which means that I don't have to worry about whether or not I've missed something. I'll know if I've missed something because I won't have 5 pairs, and that's very nice of them. Now, we're told that the triangle has area 6. We're also given 2 of the points. We don't know the third. You may know a formula. I don't off the top of my head, but I could probably find one without too much trial and error. But you may know a formula that allows you to find the area of a triangle in terms of the coordinates. And if you do, well, you could probably just use AB in that formula and get the area to be equal to 6. You'll get a few choices that are possible. And you'll be looking for integer pairs AB, and that should narrow things down for you. And specifically, I guess they'll be in the sort of first quadrant. In fact, let's sort of draw this out. We're just going to focus on the first quadrant, 0 up to 10, and then our points are 1, 1, and it was 4, 5, so it's a little bit higher than it is to the right, and they called that Q. So we definitely know this is part of our triangle, but where else can we go with that? We have to deal with these ABs, so that the area is 6. Now, this would be a lot easier if P and Q were either both sort of on the same horizontal line or the same vertical line, because, well, then we could calculate the base and then figure out AB based on, it would have to be a certain height away. Obviously, we don't have that. But we might still be able to figure out PQ and use it as a base. You know, sort of imagine that this is sort of our baseline, the line through PQ, which I can calculate with. You know, I can find an equation for it. But if I imagine that's the base, and we know that PQ is, I don't know, let's say 4. Then in order to get an area of 12, if you have a base of 4, or not an area of 12, an area of 6, in order to have a base of 4, you have to have a height of 3. And so what we'd want to do is look for points R that are 3 away. But they could be 3 away anywhere on these, by being on these parallel lines that are 3 away. So that's a plan. I'm not the happiest with that because of how everything is slanted. And yeah, sure, I can figure out the equation of this line. I suppose we could find slopes of the parallel lines that have to have the same slope. But to make sure that they're 3 away, I'm not entirely convinced that's the easiest thing to do. But it is a strategy. You know, if I think of a better one, sure, I'll definitely do that. But it is something to work out. So let's see if we can work out what PQ is as a length. So if we drop down to, I guess, what do they have in common? 4, 1 is a decent point that they have in common. We get a nice little right-angled triangle. And from 5 to 1 is 4, and from 4 to 1 is... oh, it's a 3, 4, 5 triangle. So we can see that PQ is 5. Okay. And... oh, now hold on a second. I got a 4 and a 3, a base of 4 and a height of 3. Well, here's a height of 4 and a base of 3. This triangle should have area 12, right? 1/2 base times height is 6. So accidentally, I've found a pair. So A could be 4 and B could be 1. I guess that would work. Similarly, would we have... I guess another one if we'd gone with the right angle up here, so that'd be, what, 1, 5? And those must be on these sort of, I'm going to give them some color, these parallel lines that are the right distance away. Now, because we got a base of 5, we'd have to have the distance between these lines is 12 over 5, but that doesn't really matter. We've got these parallel lines, so any height for this triangle is going to be on one of these two lines. Because if PQ is our base, the height has got to be 12 over 5. So we're just looking for integers that are on these two lines that have the same slope as PQ, but go through 1, 5, and 4, 1. So that's kind of nice. Sort of stumbled into that a little bit. What's the slope of PQ? It'll be 5 minus 1 over 4 minus 1. No, 5 minus 1. So that'll be 4 over 3. So we're looking for y equals 4 over 3x plus b. Actually, 4 and 3 are relatively prime, so as long as we start with, say, 1, 5, if we go 3 over and 4 up, we'll get two more integers. So you'll get 4, 9. If you go 3 over and 4 up again, you'll get 7, 13, which is too big. But if we go backwards, down by 4 over by 3, we'll get negative 2, 1, so we can't use that. But what if we use our other starting point, 4, 1? We could go over by 3 and up by 4 there, and that'll be 7, 5. And then you can go over by 3 and up by 4, and that'll be 10, 9. And that should be it. 1, 2, 3, 4, 5. So these are on those parallel lines. Everything works out. So I guess we could summarize saying AB is 1, 5, 4, 9, 4, 1, 7, 5, or 10, 9. And I'm confident with how that worked out. So I think it's time we just end the video there. We'll move on to question number 6 in the next video. Until then, take care and have a wonderful day.